Training Canada. Welcome back to video lecture series of PTSP. This is Dr. P. Srinivasulu. Today we are going to discuss about this wide sense stationary process. Now you see already in the previous class we have seen this wide sense stationary process. Wide sense stationary process means whenever the random process it can satisfy the two conditions. If we calculate the mean value of the random process and it is a constant, and then if you find out autocorrelation of random process, suppose it is a independent of time, whenever the random process satisfies these two properties, so we can say that it is a wide sense stationary. Next, today we are going to discuss about jointly wide sense stationary process. Jointly wide sense stationary process means the same concept of wide sense stationary process. The only change is here, we are going to be consider two random process here. Previously, a single random process at a different time. Now, here, two random process. Suppose if we consider two random process signals, one is x of t, another one is y of. Now, they are jointly wide sense stationary. If we calculate the cross correlation between these two random process, and then it is a independent of time, so we can say that it is a jointly wide sense stationary. So we know the formula of cross correlation. So here previously there is a Rxx, now it is a Rxy. So cross correlation between two random process, nothing but expected value of x of t1, expected value of x of t1 into y of t. And then this, the difference between t2 minus t1 is nothing but tau. Suppose if you want to write t2 in terms of t1, so t2 is equal to t1 plus tau. So expected value of x of t into y of t plus tau. After calculation of this, suppose it is a Rxy of tau, that means independent of time, then we can say a jointly wide sense stationary. Now again you need to check two random process. First one x of t, we calculate the mean value and it is must be a constant. Second random process y of t, expected value of y of t, and it is also a constant. Third one, if you calculate the cross correlation between these two random processes x of t and y of t, it is a independent of time, then we can say that these x of t, y of t random processes are jointly wide sense stationary process. Next concept is strict sense stationary process. Strict sense stationary process. Strict sense stationary process means whatever the concept of this jointly wide sense stationary process, the same process we are going to be extend for this strict sense stationary process also. Whatever the random process we are considering, in that random process, at a different time instance, we have chosen, we have seen already for autocorrelation also. Only there, two time instance. Now here, the time instance we are going to be consider n. This concept is extended for n. Now if you observe here fx of x1, x2 and so on xn, and corresponding x1 is t1. At this instant t1, that corresponding value, t2 corresponding value. It is equal to, now Autocorrelation already we know. We see this T1 plus delta T, T2 plus delta T, T3 plus delta 3. Like that, if you write this one, T1, you see T1 plus delta T and T2 plus delta T and so on. If these two are same, if these two are same, then the stationary process is called strict sense stationary process. Now, if you see one problem, then we'll get a better idea what is this statements. Anyway, it is somewhat little bit of confusion these words about the stationary, first order stationary, second order stationary, wide sense stationary, giant wide sense stationary, this strictly sense stationary. So all these things somewhat difficult to remember. Better if you see the problem, you can easily understand. If you observe this one, a random process y of t is given as y of t is equal to x of t into cos omega t plus theta, where x of t is wide and stationary random process with omega is a constant and theta is a random phase independent of x of t, independent variable, uniformly distributed over a period of pi to minus pi or minus pi to pi. Find expected value of y of t and then correlation, cross correlation or auto correlation between the two. Now, first of all, you observe the given signal random process y of t is equal to x of t into cos of omega t plus theta. Here, this theta is an independent variable. So, and one more thing is, it is a uniformly distributed. He has given that interval is from pi to minus pi. So, you consider this uniform density function f theta of theta is equal to, 1 divided by 2 pi in the interval minus pi to pi, and it is 0 otherwise. Now, whether it is a wide sense stationary or not, we need to see the properties of mean value and correlation, right? Autocorrelation. Now, expected value of y of t is equal to, we can write, instead of y of t, he has given that value x of t into cos of omega t plus theta. Now, this expected value of y of t, this expected value of y of t is equal to expected value of x of t into expected value of cos omega t plus theta. Because these are two signals here. It is a one random process, it is another case. Now, we need to remember this point. When it is going to be right means, x of t and theta are independent. Now, it is a function of t. It is a function of theta. So, whenever these two random process, it is one x of t one random process, cos omega t plus theta is another random process. Whenever these two are independent, this formula expected value of x of t into y of t is equal to expected value of x of t into expected value of y of t. So we are writing individually. And then we need to calculate this expected value of cos omega t plus theta. So expected value of cos omega t plus theta is equal to integral minus infinity to plus infinity. And whatever the instead of x you copy here, and corresponding probability density function, that is he has given f theta of theta into theta. So this angle, the relation, whatever the interval is also he has given. So the limits changed from minus infinity to plus infinity to minus pi to plus pi. Because it is a uniformly density function, within this interval, this f theta of theta is nothing but 1 by 2 pi. So finally 1 by 2 pi integration of cos, it is like sine. If we substitute sine omega t plus theta, we are doing integration with respect to theta. Okay. So you substitute these limits. So 1 divided by 2 pi sin omega t plus pi minus sin omega t minus pi. So it is equal to, we observe this one, 1 divided by 2 pi expected value sin omega t plus pi minus sin omega t minus pi is equal to 0. What is the sin omega t plus pi? What is the sin omega t minus pi? You see. So this one and this one, sin omega t plus 180. That, all silvers, that one, you identify trigonometric theorem. And then it is going to be get sin omega t minus sin omega t is going to be get 0. So it is a constant. Now, you need to calculate autocorrelation between y of t. So RYY of tau is equal to expected value of y of t into y of t plus tau. So whatever wherever we have a y of t, you copy here. Wherever you have a y of t, in the t, you take t plus tau. So you substitute this one, and if you see, after substituting this one, if you observe this one, here there is a expected value of x of t, into x of t plus tau, nothing but rxx of tau. Now, if we observe here, it is like a cos A cos B. So it is a cos A plus B plus cos A minus B. If you substitute that formula and then you distribute this expected value. Now, if you observe this one, this is a cos signal. It is a cos signal. So, whenever if we calculate this expected value of this random process signal, area under this cos or sine is always 0. Now it is not a function of time, so you can write expected value of cos omega tau. So it is a constant. Expected value of constant is a constant. You simply copy here. So finally observe here this ryy of tau 1 by 2 into rxx of tau into cos omega tau. So it is not a function of time. So whenever it is not a function of time, then we can say that it is a independent of time. Okay. We will see in the next class about this time average of random process.